Hey, it's Mrs. Francis here, and in this video, we'll be looking at polynomials and how to decide how many roots we have and what kind of roots we should be expecting. Now, the first thing you have to understand is what's a complex number. And a complex number is a combination of a real number and an imaginary number. Now, complex numbers do include real numbers like -5. It's just that in that case, the imaginary part is equal to 0. So shaded in green is all the real numbers. We have rational, irrational, and so forth. And shaded in blue here, we have imaginary numbers. And these are all examples. So what's a complex root? Well, a complex root are just complex numbers. Right. The first theorem we're going to look at is the fundamental theorem of algebra. Right? So if we have a polynomial with complex coefficients, we know we're going to have at least one complex root. The corollary to that is even more important, that an nth degree polynomial has exactly n complex roots. So at this point, you're probably thinking, what is this lady talking about? Well, if you look at the degree of the polynomial, it can tell you how many roots you have. So a 5th degree, we have 5 roots. A 4th degree, we have 4 roots. A 3rd degree, we have 3 roots, so forth. Now, we're going to consider 2 additional important theorems. We're going to let A and B be rational numbers. And the first one is the irrational root theorem. An irrational number is a number that cannot be written as a simple fraction. It's non-repeating, it's non-terminating, and numbers such as pi, square root of 2, square root of 5, those are all irrational numbers. The irrational root theorem says that if you have one irrational root, you have the conjugate as also an irrational root. So, for example, if we have root 2, we know negative root 2 is a root. If we have 4 plus root 5, we know 4 minus root 5 is a root. If we have negative 6 minus root 3, we know that negative 6 plus root 3 is a root. They come in pairs. Irrational roots come in pairs. The same thing is true for imaginary roots. If we have an imaginary number as a root, it can be in the form of a plus bi. Then the conjugate a minus bi is also a root. So if 5i is a root, negative 5i is a root. 2 plus 3i, 2 minus 3i. Negative 1 plus I, negative 1 minus I. These are all pairs. The most important thing you need to remember is that irrational roots and imaginary roots always come in pairs. All right, let's look at some cubic polynomials with different types of roots. So here's a polynomial, a cubic polynomial with 3 real roots, so we know we have 3 x-intercepts. This next one, we have 1 real root and 2 imaginary roots. So if they're imaginary, they don't cross the x-axis at all. So here's our x-axis, we only cross once. And this last one, the only other scenario we have left is if we have a cubic polynomial, we could have 1 real root and 2 irrational roots. And irrational roots cross the x-axis. So if this is the case, we're going to have 3 x-intercepts. But wait, I know there's more. One more really important one, the rational root theorem. This rational root theorem is going to help you figure out what the possible rational roots are for the polynomial. And the most important thing you have to recognize is when you have a polynomial, we're going to be looking at this value here, this is p, and the coefficient of the first term, if we're in standard form, this is q. And you can use the rational root theorem to find any possible rational roots for your polynomial. So for example, here's a polynomial. This is q. Q is the value of 1. And p is the value of 6. So we need all the factors of 6 divided by all the factors of 1. So p divided by q. And that gives us these possible rational roots. So let's look at an example. We're being asked to find all the roots for this cubic polynomial. Because it's cubic, we know that we can expect exactly 3 complex roots. We also know that we're going to have one of 3 combinations, either 3 roots, 2 imaginary and 1 real, or 2 irrational and 1 real. And the possible rational roots for this particular polynomial are plus or minus 1 and plus or minus 2. So the next thing we're going to do is we're going to test all of the roots using synthetic division. And we know we're going to have at least 1 real root. So we test 1, we test -1, 2. Finally, we get to -2. That's a root. -2 is a root. Now, if you notice, we have now reduced our cubic polynomial and we have new coefficients for our quadratic. So we're going to have 1x squared minus x plus 1. That's our reduced polynomial, and we're going to have to now solve that. Well, unfortunately, this quadratic is not factorable. We're going to have to use the quadratic formula. So we go ahead and substitute our numbers into the quadratic formula and simplify, and we get 2 more roots. We get 1 plus or minus I root 3 over 2. These are also roots. So our final solution for that example gives us these 3 roots. Okay, that was a lot. You're probably going to have to watch some of these slides, go back and forth, watch this a few times. Good luck, everybody. I know you can do it.